This call is now being recorded.
Okay, so our internet is back now, and most of you have already joined, so we can start. Okay, shall we move ahead? Shall we start?
Yes, sir.
Yes, sir. Okay, thank you. So we are moving ahead. So in the last class, we have discussed about manufacturing of gears. There we have seen the several possibilities of manufacturing of gears, and which may be of from made from different materials like metals. We can have from polymers, etc. Okay, and there we have seen what are the like hobbing, shaping, saving. These are the kind of most frequently used machines for cutting of gears. Okay, which are used for in different sectors like automotive, agriculture, in different construction equipment, etc., etc. But we have also understood about the proper selection of gear manufacturing process based on the economics, based on the process capability and all. Later on, we have discussed about like how we generate the basically we can produce gear treat by machining, mostly based on the forming process and generation process. There we have discussed that this, even though we are saying like this gear forming process, basically we are talking of machine. They comes under falls under machining process like milling, grossing, etc. Okay, so now today we'll be going through a process of gear treat making, which is form cutting. Form cutting means, and we'll be discussing under this the form milling operation. Now in this particular cases, as the word itself is there, form means some shape is there. Okay, so in that case, in form cutting, what basically happens, the cutting tool, it is similar to the form milling cutter, which is made in the shape of the space between the gear teeth. So as right now we are talking of manufacturing of gears, so the form cutters basically we know that they have got a certain shape, okay, certain shape of cutting, and after cutting through the shape form cutters, actually we get that particular type of form. Okay, so in that particular case here, whatever the form tool we are going to utilize, so those form cutter, it will be made in the shape of the space, the gap between the gear tooth. Okay, and that particular portion, that means we are going to eliminate, because these are all machining process, we are going to eliminate some materials. Okay, and which portion we are going to eliminate, so basically the space between the gear teeth, that is the width of space, that particular portion will eliminate as per the required form. Okay, and which particular part will remain, the after the whole process is over, actually the portion which will remain, it will resemble the actual required gear tooth profile. Okay, and which portion we are cutting the intermediate spaces. Okay, so now what basically, how basically we do here. So now here, as we know, we'll initially we'll be having the gear blank. Okay, and that from that gear blank, actually throughout the periphery of the gear blank, if we cut that particular, or if we are producing that particular required teeth profile, then our job is done, then we can say that the gear tooth has been made. Okay, and here the gear tooth shape, it is reproduced by machining the gear blank around the periphery. Okay, so throughout the, you can consider as if circular blank that we have, and throughout the periphery we're actually cutting that particular or machining that particular toothpaste. Okay, and here what happens, the cutter, which will be prior to going to the process, let me show you the figure, then I think it will be more evident. So we can have this kind of shape. Okay, this kind of form cutters. Okay, this one we are showing different uh, cutter. Okay, so similarly here in this particular process, in this particular figure, we are showing a production of gear teeth on a particular blank by a this kind of form cutter. So now what happens here, we have this gear blank, and throughout the periphery, if you see, all around the periphery, if we can cut this particular shape, okay, with the width of space in between, okay, in between the teeth, then our job is done. So in that case, actually we are for doing so, we are actually using this form cutter. So these are the actual look of the form cutter, different form cutters, and these form cutters, actually the shape of them, it is made which corresponds to this particular shape, width of space. Okay, that space between the teeth, okay, it corresponds to that particular shape. And after, ultimately, if we suppose in this side as well as in that side, in both the sides of the teeth, if we actually eliminate the material as per the requirement, then whatever will remain, that is nothing but the required tooth profile. And if we do so throughout that particular periphery, our job is done, and that is what is actually this form cutting. So now during this process, so the cutter, it travels axially along the length of the gear tooth, and it is going up to a appropriate depth to so as to produce the gear tooth profile. Okay, and once we cut this particular, suppose that particular portion through this cutter, if you consider, suppose if we now like the full depth has been given and appropriate cutter, appropriate at appropriate portion we are cutting, then throughout this particular length also. Okay, so throughout this length, if we do so, then this portion is eliminated. And next, as per our requirement, if we do the proper indexing, I think indexing all of you have studied in your one of the machine, like I think in manufacturing technology. So next, what we do after each tooth is being cut, the cutter, we just withdraw the cutter and the gear blank is rotated by a particular amount. That means the indexing has been done. As per the indexing, a particular rotation, angular rotation will give to the gear blank, and now the position of the gear blank is now the position where actually we end the next cut, so that the teeth is properly cut. And thus we keep on doing the same throughout the periphery, and the process continues until the end of the whole gear blank machining. Okay, that means that all the teeth has been machined down. And thus once the whole thing is over, the process is over, we get our required teeth profile. Understood? So this is how actually by form milling actually we can generate this kind of teeth. Now in this case, all the cutters, each cutter is, it is designed to cut a range of numbers of teeth. Okay, and the precision of the form tool cutter tooth profile. Okay, it basically depends on the accuracy of the cutter and the machine, and whether the machine is what is the accuracy level of the accuracy and precision level of the machine on which you are using it, whether there was any kind of unnecessary noise, vibration, etc. Okay, whether those has been properly dampened or not, depending on that, whatever is the stiffness that you have got. So based on that, actually the precision of the form cut tooth profile will depend. Okay, and even if you say it is not a very efficient method, but still form cutting it can be done on milling machine also. With the cutter, it can be mounted on the arbor, and on the dividing head of the milling machine we can mount that gear blank, and properly it can be indexed and so, and sequentially we can cut the teeth profile. Okay, so that is how basically this process is done. And what are some of the characteristics? So now we know we are talking of using a form tool cutter. So this particular cutter, it has got a certain geometry, and this geometry is fixed. That means within the process it is not varying. So as that is happening, because of that, a form cutting, it can only be used to produce gear teeth that have a constant width. Okay, so as it is not changing like that. Okay, it has got a fixed geometry, so it is suitable for producing all the spar gear and all. But like bevel gears, where actually throughout the it doesn't have the constant weight. Actually, it is a, you already know, bevel gear. We can consider on a conic surface. Actually, it is being cut, so there it is not suitable for manufacturing bevel gears and all. And both internal gears and gear teeth on straight surfaces also can be form cut with the proper separate cutter. Okay, and actually it is, as we are talking of indexing each and every teeth and all. Okay, one space will cut, then we'll go to index, next we'll cut, we'll go to index, and so on. So it's a somewhat time consuming process, and because of that, this particular process is suitable for low quantity production. Okay, so this is about form cutting of gear tooth. And basically as we are talking of milling, using milling, so it's a form milling of gear. Understood? I hope all of you understood this. Okay, it's easy only. Porimal, understood? I think you are not in this call. Okay, so next type of manufacturing of gear will be discussing. Okay, thank you very much. So next type we are going to discuss is broaching. So here also the broaching also is a way to form cut the teeth. So that means we are going to have a form tool cutter. Now in this process, actually like for most producing the internal teeth and all. Okay, it's a very suitable process, and it's a very fast process. Now I think from this figure it may not be that much visible to you. So sometimes what basically this figure designates. Okay, so what we can do in this particular broaching process, we'll have this particular broach of required the whatever is the form that we require as per the teeth profile that we have to machine. So we'll be using that particular broach. And I believe all of you recall about broaching process from your manufacturing technology. Do you remember this kind of broaching tool that you have seen? That is the progressive tool, where in a single sequence we have multiple cutters. Okay, actually they progress the elevation of them, actually that is changing, and it keeps on like initially the first cutting edge will come into contact with the surface, next next, and that means a row of teeth we generally have row of cutting edges. So do you recall about broaching from your manufacturing technology knowledge? Do you remember seeing this kind of broach in your manufacturing technology, one or two? So that particular process, those broach tool right now, which will be in the form of that required shape of this particular teeth, okay, that particular part we are going to machine from this teeth. So that kind of broach tool we are going to utilize. And generally, if you have forgotten about broach, so the broach in the broaching process, we use a tool known as the broach, and which is a kind of multi-point tool, and it has got a row. It has got a, if you, it is evident from this figure, it has got a row of your this kind of teeth cutting edges. Okay, and in our case, as we are talking about producing the gear by machining, so which part will be eliminated? The eliminated part will be that width of space, the space between the teeth. Okay, that portion we are going to eliminate, rest will remain as per the required shape, and that is how we are going to generate it. Okay, so this brush tool, it may be circular brush also, and this kind of flat brush also it is used, where you can see here a row of teeth are there as per the cut shape. Okay, whatever we are going to do, whatever we are going to machining, right now we are going to machine teeth, internal or external teeth. And this process basically it's very suitable for producing internal teeth. Okay, and how we progress with this particular process now. If you look at this particular figure here, after I share this ppts with you, maybe the figures will be more evident. So here all the tooth spaces, these can be cut simultaneously, and tooth head are formed progressively, okay, sequentially, okay, one after another. Okay, so there will be multiple cut because a row of teeth are there which has got slightly different elevation. Okay, increasing elevation. So initially one small amount of material will be removed, next cut edge cutting edge, it will remove another layer, next another layer, and so on. And once the whole pass is over, so we actually get our whatever is that profile of the cut. So in this particular figure, this circular table, it holds 10 sets of progressive tooling. So here you can, if you can see the numbering 1 2 3 4 like that, so 10 sets it is there. And as the table rotates, it's a rotating tool. Okay, this is one way of doing broaching to generate teeth profile. Okay, so now as the table rotates, moving one set of the tooling at a particular time under two workpieces. And these arms, we have got these arms here, they load and unload a set of parts every 15 seconds. So every 15 seconds, it is a particular process we are saying. So you can see the cycle time is very less here. Okay, so it's a very quick process, that means. And this brushing says somewhat repeat, and it can produce very fine surface, and the dimensional accuracy that we get is generally more. Okay, now once again, as we are talking of doing this broaching, and we know that this kind of a particular broach tool will be required to do a particular broaching operation. And one particular type of tool, you will have a certain dimension and certain geometry. So because of that, what happens, because of that, a different broach will be required for each gear size. And these broaches are actually, this broach tool, they are actually kind of expensive. And because of that, this broach tool is suitable for high quantity production only. If you say that I'm going to use broaching and all for generating very small quantity, then not, it is not that much economical. Okay, and it's this particular broaching, it's very suitable for producing internal teeth also. Right now you can see in this particular figure, so this, it is a broaching of internal teeth. The work has been held in this particular chuck. Okay, and this kind of circular broach that we have. So along the periphery of it, if you look at properly, we have a row of teeth, cutting edges. So this way we have one row, another, and another, and so on. So when it comes into contact with it, a series of gear teeth can be machined simultaneously. Okay, similarly we can have flat kind of thing. So the internal teeth, the spline also, here we are showing spline mentioning. Okay, spline also can be machined with this particular broaching. Okay, and you can even use this broach tool with in your lathe also, no problem. So you can hold the jaw like this, or job like this, and depending on whether it is external teeth or internal teeth that you want to manufacture, maybe this surface or that internal surface. At that internal surface, you are going to have the bossing process. Okay, understood? So here mostly whatever we have discussed, this is kind of the ways of manufacturing gear. So apart from that, through brushing, that means we can also get some other other kind of shape also, no problem. Okay, but we are utilizing broads to manufacture gears. So next, whatever we have right now discussed, those are gear forming only. Okay, now we'll be discussing about gear generation process, gear generating process. Now here this various most of the very high quality gears, and they are generally made by machining, okay, by this kind of generating processes. They are actually what is the main principle involved in gear generation. So the process of gear generation, okay, this generating process, it is based on the main principle that if for any two involute gears or any gear on a particular rack, okay, of the same diametral pitch, they will mesh together properly. So as we already know from our theory of knowledge, theory of machines knowledge, so when two gears they have got the same diametral pitch, they are going to mesh properly, okay. And utilizing this kind of principle, that means if we can get uh, two gears and or a gear with a rack, okay, having the same diametrical pitch, they are going to mesh. So utilizing this principle, so what we can do, and what is generally done in this gear genetic process is that one of the gears or that particular rack, it is made into a cutter by proper sharpening. Just like in the case of previous threading process also, you have seen that just like in the your using of thread by dies and all, you have seen that it behaves like a nut, but we have got cutting edges there. So similar is the case here. The main principle that when the two gears meshes properly, that particular principle we are going to utilize, and utilizing that, we are going to produce that particular tool. And that tool will be in the shape of the gears, but will be having cutting edges and by proper sharpening. And now what we do next, what we'll do, we'll try to mesh them, so it is then used to cut into a mating gear blend, and thus it generates the required teeth on that work plank. Okay, so that is what is the actual generally this is the principle behind gear generation process. Now, what are the two basic methods, two main methods by which employs this gear generating process? It is one of the shaping process, gear shaping, and another gear hobbing. Okay, so what generally do we do? The cutting tool it is used in gear generating. It may be pinion shape cutter or a rack shape straight cutter also, or sometimes it can be a hob. So what is hob? We are going to say next. So basic thing is actually we are going to employ the principle of gear meshing, okay, where we see a diametrical pitch, if it is same, it masses, okay. And after that, the cutter itself will be in the shape of the gear, okay, meshing gears, and but it will be having the your cutting edges, sharp cutting edges, okay. So that is the principle, and that principle we employ in both shaping as well as hobbing process. So now what is shaping process? Gear shaping. Now in this shaping, in this particular figure, you can see that actually we are talking of one work. Okay, work means the gear blank on which we want to cut the gear teeth on its periphery. Okay, and we'll be having a suitable cutter for for producing a required gear teeth profile. Okay, so how we proceed with this particular topic, particular process? Now, in this particular process, to proceed with this particular shaping process, okay, so initially what we do, the cutter, which is this one, the cutter and the gear blank. Gear blank is the work where we actually want to have this particular, we want to cut the gear teeth, okay. So initially they must be attached rigidly to their respective shaft. So respective shaft means the position, the proper position on that particular shaft where we have to mount them. And then the two shafts must be interconnected by suitable gearing, okay. So on the shaft it will be there, so that this particular, suppose cutter, this is this one, and this gear plane, second one, they rotate positively with respect to each other, and they are fed the same pitch line velocity. So it is just the reverse of normal gear meshing. So our end intention is to produce the gear. Okay, the principle is, we know that when two gears meshes, that particular principle we know. The cutter initially will have the shape will already be given. Okay, but the cutting edges, this teeth profile, which are the cut itself becomes the teeth cutting edges, they are very sharp. And this work initially, it will be the gear blank, that it will not be there initially, but after the process is over, we'll get something like this. That is what is our intention. And so as to get it, initially the work where there will not be any teeth, and this kind of cutter which has already got these shapes. Okay, so the on that particular proper shafts, okay, the position is rigidly held, and those shafts are properly rotated positively by means of gearing. Okay, and that ensures that whenever this particular suppose shaft will rotate, the other will rotate. So positive velocity we give them. Okay, and we allow them to have same pitch line velocity, because we know that when actually two gears they are in proper mesh, actually they rotate with the same pitch, their pitch line velocity is same. So that is how we so as to get the teeth in its proper position, we ensure that they have got the same pitch line velocity. Now, to start cutting the gear, what we generally do, the cutter, which is this one, right hand side one, the cutter is reciprocated vertically. So this way it will be vertically reciprocated throughout the length of this particular gear blank, where we require the teeth to be cut, as well as it will be fed radially. So this way also along the radius, so infeeding will be given, so that we can ensure the full day. Okay, so and it also it is fed radially into the gear blank between the successive stroke. And when we get the desired tooth depth, okay, the cutter and the gear blank, this is the cutter, this is the gear blank, they are then slightly indexed after its cutting stroke. Okay, that means so this cutter, what will do, it will infeed come within this way. Okay, infeeding will be given, as well as it will reciprocate like this. Okay, so in that case, what will happen, wherever it meets the cutting edges, okay, the cutting edge, it is going to eliminate some material. Okay, and next we'll do the indexing. That means we'll rotate the job by a proper amount, so as to get the cutting in the next week. And once we do this for the whole 360 rotation of the gear blank, the job is over. And by this particular process, either straight or helical tooth gears, it can be cut on the gear shapers. Okay, and because the cutting stroke, it can be adjusted to and at any desired point, the gear shapers, okay, they are particularly useful for cutting a cluster of gears. Okay, and also for internal gears also, we can adapt it. Okay, we can have it, so initially the bigger hole will have a proper this gear cutter, this kind of shaping cutter, it will be there, and we can progress with the process. Okay, and that is the and here in this particular case, in this particular figure, we are actually showing the generating action of a like for a fellow gear cutter. Okay, and a series of photographs has been shown in this particular lower figure. Okay, so as to like it is showing the how different gear teeth are being measured here. Okay, so that is how we do this particular shaping process. Yes, understood? Yes, have you understood or not? Let me know. Okay, thank you. So the next process that we are going to discuss is hobbing of gear. So this is once again, it falls under the gear generating process only. Okay, so here this particular process is very much suitable for can say in industrial gear. Okay, these are also being produced by this kind of hobbing process, and it's suitable for your even very mass production also. Now, what is this hobbing? So how we do with this, how we proceed with this hobbing process. So just like in the case of prosing, here also we'll be using a particular tool, and actually that particular process is known as the hob. Okay, hob is the tool, hobbing is the process. Okay, and now what is the look of this particular hobbing tool? So hob, which is nothing but the tool that we use in the case of hobbing. So it is hob, it's a basically is a gear cutting worm, okay, worm or a kind of screw, which is made into a gear generating tool by by providing a series of longitudinal slots or gases meshing into it to form the cutting teeth. So if you look at this particular figure, so actually this is the hob, okay, we're talking about. Okay, so all the figures are showing the similar kind of thing only. So but these figures, these are the one view. So actually it extends like this, okay, this way or that way you can see. Okay, so the different views of the hub actually that we are showing. Okay, three views of the hub at the gear blanks. Okay, so in that case what happens, you can see a series of actually this kind of teeth it is there, right? So now as you can see, actually it looks like a kind of worm, right? Worm and wormhole, if you recall, actually it looked like this particular worm. Okay, so here, okay, which is nothing but a kind of screw only. We have discussed only in the theory of machine, worm and wormhole you have already discussed. So it this particular thing is being this gear cutting worm. Okay, it has been made into a gear generating tool. Okay, by providing a series of longitudinal slots. Now when we are talking of having a spur gear, now, what we generally do, the angle between the hub and the gear blank axis is 90 degree minus the lead angle of the hub trace. So as we are talking of the hobbing, which is something kind of a the worm, or it resembles the kind of screw, but we'll having the rows or series of cutters. Okay, so in that case, when we are talking of having a spur gear axis, okay, so the angle between the hub and the gear blank axis is, it is 90 degree minus. So if you see this particular is the, if this one view, okay, this is the axis for the hub, and that way in inside the your plane, this way the gear blank is there. Or another view is this one, okay, this is the one of the axis and this is another axis. Okay, so how basically they are tilted, so it is 90, as you can see, it somehow looks like as if they're at 90 degree apart, the axis, but actually it is not exactly 90 degrees. So it is 90 degree minus the lead angle of the hub thread. Okay, so now here in this particular case of hobbing, so all the motions in the hobbing, they are rotary motion only. Okay, and this hub as well as the gear blank on which you are going to initiate or manufacture that particular teeth, they rotate continuously, just like two gears which are in mesh, until all the teeth are being cut. Okay, so as you can see in this particular figure, so that will be evident here. So if we rotate like this, actually, okay, if you look from this particular view, okay, so if the hub is given this kind of rotational motion, and already the tilting has been done 90 degree minus this whatever is the lead angle of this particular hub, so and it is given the rotating motion, then what happens, wherever they are in contact, this portion at this portion, actually it is going to cut out that particular material, right? So here you can see in this particular view how the hub axis and the gear blank axis, actually this is the axis, this is under axis. So for this gear blank, it is tilted by this 90 degree minus this particular whatever is the angle thread lead angle of this particular hub. Okay, so this is the gear blank lower portion, this is the hub. Okay, this way, and hub is rotating like this. So during that case, what will happen? In this side you can see, actually wherever the hub is in contact, hub teeth are in contact, this particular series of teeth that we have here, the rows. Okay, so here and here, everywhere it has machine teeth. Okay, so that is the thing. So these hubs, they are generally available with one, two, or three leads. Okay, so for example, if the hub it has got a single thread and the gear it has to have 40 teeth, then the how what we have to do is the hub and the gear spindle, it must be geared together, so that the hub makes 40 revolution while the gear blank makes one revolution. That means single threaded hub is nothing but the cutter, and we want the gear to have 40 teeth. That means we should be able to cut 40 number of this kind of teeth. So whatever is the proper gearing you do for this, both the spindle of the hub and the plank, so actually how should you ensure it? Okay, you should ensure that In that case, the hop should make 40 revolution, and during that process actually the gear blank should make 1 revolution. Then we can make sure that if it is single threaded hop, okay, so then within that particular thing, okay, the throughout the periphery of the gear blank actually 40 number of teeth will cut. Similarly, if it is a double threaded hop, then if we require 40 number of teeth to be cut, then the hop should make 20 revolutions, and the gear blank it should make 1 revolution during that time. Okay, so then we can ensure that double threaded hop it is going to cut 40 number of teeth within that 20 revolution of the hop. Okay, and apart from that, as we are talking of this cutting action, so the depth should be given. So the hop it must be fed parallel to the gear axis for a distance which has to be greater than the face width of the gear tooth, so as to produce straight teeth on spar gear. And there is very interesting properties there. So right now the same hops it can be used as well as the same this particular machine, so as to cut helical gears also. But in that particular case, the axis of the hop it has to be slightly tilted so as to generate the helix profile. Okay, so the same hops and machine you can use to generate spar gear, also to helical gears. But in that case, the orientation, the tilting will be there. Okay, and this particular hopping process it's very rapid, very fast, and this is one of the very like one of the method by which most of the gears are being cut, and even the all the splines, sprocket, those things also can be manufactured by this hopping process. Okay, understood? Yes, have you understood hopping process? I hope you have understood. So similar to your thread rolling or other other form rolling operation. So now we can also like utilize this cold form rolling operation to produce gear also. This process already we have discussed in your under rolling itself. Okay, so what we can do here, just like the case of other rolling process, so here also we can use the foam rollers, so as to, which resembles the shape of this particular gear tooth that we will be requiring. Okay, and we can utilize this, and the proper compressive force etc will be provided through it, and during the process actually the whatever is the teeth profile, required teeth profile, that resembles the foam rollers. Okay, the foam roller has to be given that particular form of this particular tooth profile which will be requiring. Okay, so based on that, ultimately once the process is over, rolling process is over, just like other process, just like thread rolling, rolling of other form rolling, etc. Okay, this is one type of form rolling only. Okay, and right now this can be considered as rolling of gear because the end product is nothing but the gear. Okay, so once again this can be done with the help of your flat die, just like in the case of thread also, and your circular dies also we can consider. So it's possible to properly utilize this process, these rollers, even for manufacturing this kind of helical gears also, or the worms also. Okay, so but in that particular case, the rolling rollers, which are acting like the die, so they should have that required profile. Okay, and on this particular process is over, so this is a cold forming process. So in the with respect to cold forming, the advantages associated with cold working process, those will be associated here. That means the strength is kind of superior strength that will get, and whatever is the dimensional accuracy, etc. Okay, those are also good. Okay, as well as the there is another advantage of playing with the fiber flow lines. Okay, so that is how also we can generate gears. Apart from that, we can go for various non-conventional machining process like wire EDM, or even all those PCM photochemical machining, etc. So we are discussing one of them, that is wire EDM. So in that particular process, this is very whatever it will be very like geometrically accurate, but finishing of the gear tooth it may be moderate kind of thing. So both here as it is evident in this particular figure, so internal gear as well as the external gears they can be cut. Okay, so like, but if we're talking of this wear idiom process, so this is restricted to material which are conductive only, because the spark has to be generated within the wear and the workpiece, and it should cut. Okay, so I believe you have already studied about various non-conventional manufacturing process. Under that you have studied wire idiom, EDM, PCM, etc. So this wire idiom, where the wire becomes the tool, So very fine wire is used there, maybe of like 200 micron to, it ranges from 200 micron to 400, 500 micron. Okay, that kind of fine wire we can utilize. And in the design can be given. So generally they are CNCs only. So as per that particular design, actually either the tool or the workpiece, that work table, it gets that particular type of movement. And during that process, so actually a very small event it, because the tool that we are using, that is only a fine wire only, okay, conductive wire generally made of molybdenum and all. Okay, so with this, actually if it cuts like this, okay, if it moves like this particular design of this particular teeth profile, and once the process is over, we are going to generate a profile like this. Okay, suitable both for internal as well as external diameter, external diameter. Okay, so these are some various type of gear manufacturing process. So with this we'll stop here today. In the next class we'll be discussing about the various gear finishing process. Okay, how we can go for finishing of the gears. By finishing, we don't mean that we are finishing it, that means like totally destroying it or that kind of finish. That finish we don't want. Actually, we are utilizing the finish, that means the last stage. Okay, making it like highly polished or that kind of thing. Okay, par free, defect free, and all. Okay, so with this we'll stop here today. Let me know whether you have understood or not. Okay, I hope all of you have understood the things. If there is no question, we'll stop here today. Thank you everyone for joining. Okay, thank you, Bhaskar. I'm ending the meeting now. Thank you everyone.